Hello and welcome to Mathematics with Simon. I'm Simon. Today is Divisibility Rules, the sequel. Why do they work? So last time we explored divisibility rules for 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. But I couldn't escape a simple question. Why do they work? So it's possible to use a rule without knowing why it works. But actually, knowing why helps us to be more confident in the rule, helps us to understand it better, and maybe helps us to invent new rules in the future, maybe develop new rules in the future. So it's really good to understand why, and in some cases we're looking for a proof of why the rule works. So proof's very important in mathematics. In mathematics we want things to be proved so we can be sure that they're true. So what I realised is that understanding these rules depends on a simple fact, which is a number is divisible by 3, say, if and only if the number minus 3 is divisible by 3. So taking 3 off a number doesn't change whether or not it's divisible by 3. 33 is divisible by 3. If we take 3 off, we get to 30, which is also divisible by 3. And actually, more generally, x is divisible by y if and only if x minus y is divisible by y. So taking y off x doesn't change whether or not x is divisible by y. Okay, how does this help? Well, let's start with the rule of 9 as an example. So the rule says a number is divisible by 9 if the sum of the digits is divisible by 9. That's what the rule says. So, for example, is 1,233 divisible by 9? Well, let's add the digits. So 1 plus 2 is 3, plus 3 makes 6, plus 3 makes 9. So yes, it is, because 9 goes into 9. But we can actually work this through using this insight by taking away 9. So if we take away 9 3 times, we take away 27, so we get rid of the 30, but we add on 3 more. So we basically just move the 3 from the 30s column and we add it onto the units column. And then if we take away 9 20 times, we move the 2 from the hundreds to the tens. And we take away 9 another 2 times, twice more, and we move the 2 from the tens column to the units column, so it's 1008. Finally, we take 9 away another 111 times, which tells us that 1008 is divisible by 9 if and only if 9 is divisible by 9. Now, is 9 divisible by 9? The answer is a definite yes. In general, if we're given the question about whether UVXY is divisible by 9, we subtract 9 x times, and then 11v times, and then 111u times, to show that this is the same as asking whether u plus v plus x plus y is divisible by 9. So here we've actually proved that the rule works. Okay, what about the rule of 2? Well, okay, let's look at an example. Let's ask if 3,592 is divisible by 2. Okay, the result will not be changed by taking 2 away 45 times. So this is a bit like asking whether 3,502 is divisible by 2, because we've taken 2 away 45 times, which means we've taken away the 90. Then we take 2 away another 250 times, and we take away the 500, and another 1,500 times, and we take away the 3,000. So we come to the question about whether 2 is divisible by 2, which we know is a yes. The point is that we can forget about everything in the tens, the hundreds, the thousands column, because it's all divisible by 2, so it's only the units that matter. We only care about the units column because all the rest of it's divisible by 2. Same works for the rule of 5. So if you've got 234,765, we can take away 5 12 times to get rid of the 60. We can take away 5 140 times to get rid of the 700. And the same with the 234,000. We can take 5 away a large number of times to get rid of all of that as well. All we care about with the rule of 5 is the last digit, and the last digit is 5, or also if it had been 0, that's absolutely fine, and that tells us the whole thing is divisible by 5. Same is true for the rule of 10. So 10 goes into 60, 10 goes into 700, 10 goes into 234,000. All we care about is the last digit, which is 0, so the whole thing is a multiple of 10. The rule of 3 is like the rule of 9. So we've looked at rule of 9, we've looked at 2, we've looked at 5, we've looked at 10. The rule of 3 is similar. A number is divisible by 3 if the sum of the digits is divisible by 3. The proof is similar too. So given a number u, v, w, x, here's what we're going to subtract. 3w lots of 3, 3v lots of 33. This is like a big tongue twister. 3u lots of 333. But I wrote it, so I'm responsible, right? So we take away 3w lots of 3, 3v lots of 33, 3u lots of 333, which is the same as taking away 9 lots of w, 99 lots of v, and 999 lots of u. And so what that does then, for instance, taking away 99 lots of v, it removes the v from the hundreds column and it adds it onto the units column. So this is the same as asking if u plus v plus w plus x is a multiple of 3. What about the rule of 11? The rule of 11 is similar. It's a little bit more complicated. So what we're going to do is reduce the first digit and the one next to it by taking away 100 11s, or by taking away 1100. So when we take that away, 3564 turns into 2464. And we take away 1100 again, turns into 1364. And we take away again, and it turns it into 264. So we just keep on taking away 1100 till we get rid of those thousands, but that also reduces the hundreds. So now we're down to 264. Now we're taking off 110, which is 10 lots of 11. So we take it off once, 264 becomes 154. And we take it off again, which where 154 becomes 44. Is 44 divisible by 11? It certainly is. We can actually take 11 away 4 more times. Is 0 divisible by 11? Yes, it is. So in general, UVXY is divisible by 11. We start with that question. We take off 1100U. We then take off 110V minus U. We then take off 11x minus v plus u, which leaves us with the question as to whether y minus x plus v minus u is divisible by 11. Now let's think about the rule of 7. The rule of 7 is the most complicated, and personally I think it's easier just to divide by 7 than to use the rule. But still, let's look at the rule for completeness. So what the rule says is we start with a big number like 4,431. We double the last digit, so the 1 becomes a 2, and then we take that 2 off the truncated number 443. So we take that off to give us 441. We then double the last digit again, the 1 becomes a 2. We take it off the truncated number 44 to give us 42. Does 7 go into 42? Yes, so 7 went into the whole thing. Another way of thinking is actually we could double 2 and take it off the truncated number, which is 4, and that gives us 0. Again, 7 goes into 0. All the positive whole numbers go into 0. So, generally speaking, UVXY is turned into UVX minus 2y. So, to do this, each time we're taking off y21s, or 3y7s. So we're taking off a bunch of 7s. And then finally we get a number which has a 0 on the end. So to get rid of the 0, we divide by 2 and 5. Now this is fine because if we divide a number exactly by a prime, then we don't change its divisibility by a different prime. And this can be understood by looking at the prime factorization. In other words, when we look at the prime factorization, if there's a 2 and a 5 in there, we can divide them out, but that doesn't change the fact of whether there's a 7 in there or not. If you want to learn more about prime factorization, we've got a video on lowest common multiple, highest common factor, prime numbers, prime factorization, which might be worth a look. But that's basically how this method works. So we've been through all of these methods. For me, it's a great relief just to understand the mechanics behind them and how they all work, and I found it really interesting. If you've enjoyed it, please hit like. If you want to see more in the future, please hit subscribe or notification. I think next we're going to send algebra. My daughter wants to do some stuff on algebra, so we're going to look at that. Quadratic equations, simultaneous equations, just equations. Most of all, I hope you enjoy your mathematics. I hope lockdown's treating you well, and we really look forward to seeing you next time.